Hello, it's Richard Beckett here from Global Water Solutions. Today I'm going to talk to you about expansion vessel sizing for closed loop heating circuits. And this is the hydronic tank sizing. So basically we again need some initial parameters, and here are the initial parameters I'm going to work with today. The first one is the maximum temperature, nice and easy, which is 90 degrees centigrade. The next one is the total system volume. Now the total system volume is the sum of all the radiator volumes plus the pipe work in the building plus the boiler. And you have to add all those up and that will give you the total water system volume. Or a quick and ready reckoner will be the boiler kilowatts times 11 for steel radiators. If you've got other types of radiators or heat emitters, then you'll need to go on the internet and look up what is that factor for those types of heat emitters. But for steel radiators, 11 is the one I'm going to be using today. The safety relief valve pressure or safety valve relief pressure I'm using is a 3 bar, and the static height is equal to where the expansion vessel is, the height of the expansion vessel to the highest point in the building, and I'm going to be using 6 meters. Okay, so let's go on to the calculations. The first calculation is going to be the total system volume. So the total system volume is, we're going to assume a 30 kilowatt boiler, so 30 kilowatts times 11 gives you 330 litres. We next work out the water reserve. Now the water reserve is in there to compensate for the air which is in the water when you fill the system, which will be liberated via the automatic air vent once the system is commissioned and goes online. So for anything below 600 litres, we always use 3 litres, an extra 3 litres. Now we go on to the expanded volume. The expanded volume is a factor of the expansion factor, which is a chart lookup table, which is on the screen as we speak, and I'll just hold it there for a short period of time. So basically at 90 degrees centigrade you can see that the expansion factor will be 0.0386. Okay, now we can work out the expanded volume. So the expanded volume is equal to the total system volume plus the water reserve, so total system volume plus water reserve times the expansion factor. So that's 330 plus 3 times 0.0386, that comes to 12.85 litres. Now we'll work out the maximum pressure. Now the maximum pressure is not the safety valve relief pressure. We operate on half a bar below the safety valve relief pressure. So the maximum acceptable operating pressure that we work to on this calculation will be the safety valve relief pressure minus half a bar, which is 3 bar, which is there, 3 bar minus 0.5 bar, which is 2.5 bar. Okay, we now move on to the tank pre-charge. And the tank pre-charge is equal to the static pressure plus 0.2 of a bar. And the reason we put 0.2, we add 0.2 of a bar in there, is to stop any vacuuming of the system once the system is filled with water and commissioned. So the static pressure is equal to the static height times 0.1 bar per metre. 0.1 bar per metre is simply every 10 metres you go up is equal to 1 bar. So therefore every 1 metre is 0.1 bar. So in this calculation, the static height, as I said to you before, is 6 metres. So 6 times 0.1 bar is equal to 0.6 bar. So the pre-charge now is equal to 0.6 bar plus 0.2 bar, which is 0.8 bar. Now we go on to the acceptance factor. This is a factor. So the acceptance factor is derived from Boyle's law, and Boyle's law states that the acceptance factor is equal to the high pressure of the system minus the low pressure of the system in bar divided by the high pressure of the system plus 1 bar, which is atmosphere. So in this calculation, the high pressure that we've calculated is 2.5 bar minus 0.8 bar divided by 2.5 bar plus 1 bar atmosphere, which is 1.7 bar divided by 3.5 bar, which is 0.486. And that's 0.486 factor. That's a factor, an acceptance factor. Okay, so now we go on to, we can now calculate the size of the tank that you need for this system. And the total tank volume is the expanded water plus the water pressure divided by the acceptance factor. And that comes to 12.85 litres plus 3 litres divided by a factor of 0.0486, which is this factor here, and that comes to 32.61 litres. Right, we don't have a 32.61 litre heating expansion tank, but we do have a 35 litre, so you will always go one to the next size up from the calculation, and that will be our HWB 35LX. The HWB range, heating range, the Global Water Solutions heating range, comes with a 2-year guarantee, but very significantly, it never loses its pre-charge. So thereby we are, I believe, the only manufacturer that can state quite categorically that during the lifetime of this expansion vessel, it will always maintain its pre-charge. So that gives you how to calculate the size of an expansion vessel on a heating closed loop system. That's not the end of the story. In the next video, which I'll do in a couple of days, I'm going to talk about the system fill pressure, because it's very important to fill the closed loop system with new water at the correct pressure for all this to work. So I'll sign off now, and I'll see you in a couple of days. Okay, thank you.